All right, moving on to a new unit, a kind of a short unit. Kind of a short unit. A short unit. Because we are going to turn around and test next block day. The good news is... What is the good news about that? It's not a... This one doesn't really fit that criteria. This one's short so that we can fit it one more test in before the end of the 9 weeks. So this one's not. Inverses are kind of a pain, but logs and exponents. Here's the good news. At the end of next week, it's a week off. You have earned it.
This test will be short. It won't be that bad.
You're going to work in Arizona?
No. I went on a college tour in Arizona. But then when I come back from my college tour, I worked every day for the rest of it.
So you at least get money.
I would very much.
Okay, we're about to be...
Yeah, I don't want to switch my... I want to keep it.
Wait, so the test is on the 29th?
So the test is next block day, the 29th for you guys. All right, let's talk about natural logs. You just saw some of them in that little limit review game thing, and some of you were like, "Whoa, what's natural log about?" So let's review some properties of natural log before we talk about derivatives of natural log. All right, like one step at a time here. I think looking at the graph will help us remember some of these properties. Or do we do the properties first? Natural log of 1. You remember this logs are the fish hook thing, the loop-de-loop thing?
Oh.
Yes, that. What's the base for natural log? What's the little number down here? E. It's E. 10 is if it's just log. This is E. So e to the what would give me 1? E to the what power would give me 1? Because anything to this number over here would give me 1. 0. So e to the 0 is 1. That means the natural log of 1 is 0. And if we're thinking about an ordered pair here, 1 is the x value, and the natural log of 1 is 0. So 1, 0 is a point. You have to know it. I don't know that I'd say you have to memorize it, because if you think about the fish hook thing, you can figure it out. How about the natural log of E?
10.
So there's still a base E here.
Oh, 1.
Yeah. E to the 1 equals E. Of course, then we have to know what E is if we want to put that on the graph.
It's like 2.7.
It's like 2.7 something. E is a number, it's kind of like pi in that it's a weird decimal that never ends. They come from different places, but they're weird decimals that never end. So 2.7 something, that's plenty accurate for a graph. So 1, 2.7-ish, up to 1. And how about the natural log of any negative number? So, what's that? No, that is correct. Right? You can't do e to something and get a negative number. That doesn't work. So that means all the negative numbers, there is no graph over there. Here's what the graph of natural log looks like. Maybe that looks familiar. Maybe not. So there's an asymptote at 0, at x equals 0. See if we remember the properties of logs. Natural log of x to the a. You remember what you can do with that? You're doing something.
Oh, do you bring it to the front?
You can bring it to the front. So again, none of this is calculus, right? This is still like algebra / pre-cal review. And like some of the previous stuff, sometimes it helps to do the algebra steps first because that makes the calculus easier. And you might, even though we don't even know how to take a derivative of this, you can see that doing this property makes this a simpler problem, and so it will probably make its derivative a lot easier. So this is going to be another place where you can sometimes do algebra first to make your calculus a little bit easier. How about the natural log of x times y? Do you remember how to handle that? Or what you could do with that? You got it. You must have had an awesome pre-cal teacher. Unlike Natalie's pre-cal teacher, who was terrible. Yes, you can split that up into natural log x plus natural log of y. And again, you can see where, even though you don't really know how to take a derivative of natural log, this would be a lot more complicated than this. It'd be nicer to split it up. So use your algebra today. You can get out of some, like here you'd get out of the product rule if you used your algebra. You could probably guess the next property. Natural log of x over y. Remember how that can be split up? Logs and exponents kind of go together. Multiplication turns into addition. Division turns into subtraction. And again, use that, and now you've avoided the quotient rule. So, algebra, very helpful today to avoid, you're still going to have to take derivatives, but you can avoid some of the trickier, uglier stuff by occasionally doing algebra first. Makes life easier. All right, so all of that is Algebra 2 / pre-cal stuff. You've done that before. It's a little rough, I admit. I get that. But you've seen that before. Questions on any of that? Does it look familiar now that you've seen it again? 1/10 of you nodding yes. 2/10, 3/10, good. We get 4. Excellent. All right, now let's do some calculus with it. So now we're going to do a derivative of the natural log of x. This is one of those where I guess like most of the derivatives, in math, we'd love for you guys to be able to figure things out, but sometimes you can't. We just got to tell you what the answer is. And this is one of those times. Derivative of natural log is 1 over x. Well, I guess the real reason why is if you wanted to find the derivative, you could limit as h approaches 0, natural log of x plus h minus natural log of x all over h. Somehow that equals 1 over x. That doesn't help, does it? Not really. That's the definition of a derivative, but how you get from here to here, I don't know how to do that algebraically. I'd have to look that up. So I don't know how you get from here to here. This is one of those trust me moments, know it moments. But it's pretty rare that we would have you just take the derivative of natural log of x. Usually it's going to be the natural log of something else, so that the chain rule gets involved. So let's take the derivative of the natural log of an orange triangle, or just a triangle, or whatever color triangle. So let's follow the rule here. It's 1 over whatever we're taking the log of. So 1 over the orange triangle. But then the chain rule means we need to multiply by the derivative of the orange triangle. So there's a lot of chain rule today because probably none of the questions are exactly this. They're all going to have something as the argument of log. So first part's easy, 1 over the argument and then chain rule. And a shorter way to write this, how some people remember it, that's kind of long, is just the derivative of the argument over the argument. Right, the little prime thing meaning derivative. So derivative of the argument over the argument. All right, well, let's find the derivative of some of these things. F of x equals natural log 2x plus 1. So its derivative is 1 over the argument. So 1 over 2x plus 1. But chain rule, what's the derivative of 2x plus 1? 2. If you really need to slow this down, you would say, well, my orange triangle is 2x plus 1, and the derivative of my orange triangle is 2. So there's my final answer. CalcChat, of course, would probably clean it up a little bit and write it like that. That's showing a ton of work, right? The orange triangle is 2x plus 1. Its derivative is 2. Put in the pieces. After a couple of these, most of you are going to jump to stick the argument in the bottom, put the derivative in the top. That's all it takes. Now, we can make the argument more complicated to make the derivative more complicated, but just the derivative of natural log is not that bad. Argument in the bottom, derivative in the top. Number 2, y equals natural log of x cubed. So, argument in the bottom. So what goes in the denominator? X cubed. What goes in the numerator? 3x squared. And then we would simplify that. I mean, we wouldn't have to. Like, that would be a safe stop. But we would probably simplify that to 3 over x. Now that wasn't bad, but there is a different way. I don't even know if it's a better way. Because what did we say we could do with that exponent? Bring it to the front. So that's an algebra step. That's not a calculus step to just rewrite it. And then the derivative of that would be 3 times 1 over x. That's the same thing. So this one wasn't too bad to not fix the exponent, but if we did, we still get the same answer. Derivative over the argument. Y equals natural log of x cubed. So we've sort of stepped out of simple log problems, and now we've added some extra stuff. So now we got to use some of our other rules, our Tootsie Roll Pop rules, our Blow Pop rule here. What's the outermost layer here? The cube thing. So how do I handle, forget about the inside, how do I handle the cube thing? Yeah, bring the 3 down front, decrease the power by 1. Leave natural log of x alone, because we only eat one layer at a time. But then chain rule, the derivative of natural log of x is 1 over x. And again, that's a perfectly acceptable way to write that. Calc chat would probably clean it up a little bit. Y equals x squared times natural log of x. We're just reviewing all the rules that we already know. What rule is coming up in this one? The product rule. And again, sometimes we can product rule in place. Other times we want to slow down, especially if it's something new. So let's pick on some people. Natalie, if f is x squared, what's f prime? Well, if f is x squared, then the derivative of x squared is 2x. Emma, if g is natural log of x, what's g prime? 1 over x. Then the rest is old news. The rest is just putting this back together using the product rule. So f g prime plus the other way around 2x natural log of x. And again, that's a perfectly acceptable safe stop right there. But a multiple choice test is going to clean it up a little bit. The x squared over x. And it might even, this happened on the test yesterday, it got to, in fact, it was something really similar to that, but we factored out an x. Does that sound familiar? One of those test questions, you had to factor out an x. It was one where you had to find the derivative and f was involved, so you had just an f prime, something like that. So the answer looked something like that. Again, free response answer versus multiple choice answer. Equivalent, just make sure you can get from one to the other. Number 5. Natural log. 7 examples, by the way, so we're more than halfway home. Natural log of the square root of x squared minus 4. That looks a little uglier than we'd rather deal with. What algebra step would you do first? Put it to the 1/2, right? Because we don't take derivatives of roots. We take derivatives of powers. So let's rewrite that as a power of 1/2. Oh, there's an even one more algebra thing we could do. Move it to the front, which would be great. So then instead of having a square root of an x squared, that 1/2 comes to the front, and now we don't even have a square root anymore. Again, all of that is algebra, so all of that is still y equals. But all of that algebra work should make our calculus work a little easier. Remember that y prime is the same as dy dx. It's just, especially for implicit and related rates, I wanted to emphasize dy dx. If you want to start using y prime, you can. It's obviously a little shorter. So 1/2 is out front. We need to think about orange triangles. The orange triangle goes in the bottom. X squared minus 4. Mark what goes in the top. So orange triangle is x squared minus 4. What goes in the top is the derivative of the orange triangle. 2x. And again, we've got a safe stop, but we also have an obvious 2's canceling situation there, so x over x squared minus 4. If we had left that square root there, we still could get there. It would just be a really long way, right? Because we'd have 1 over all of this times the derivative of that. It'd be a mess. Eventually we get to here, but it would be a mess. So use algebra when you can, because it makes life so much easier. It makes calculus so much easier if you know your algebra and use the algebra. Speaking of, y equals natural log of square root of x over x plus 1. If we didn't know algebra, just to emphasize how terrible this would be, let's see, the derivative would be 1 over the argument, and then we'd have to do the derivative of the argument, which would be awful, because we'd have power rule, and we'd have quotient rule, and we'd have all these square roots in there. Like, that would be, I mean, this isn't wrong, it's just really ugly. Let's do some algebra on this first. Probably the first thing I do is, since it's the same as last time, I know that 1/2 can come out front. What else could I do? That makes it a little easier. One more thing I could do. I can split these up. Again, I'm still doing algebra. Natural log x minus natural log x plus 1. And put the 1/2 on both of them. Again, I still haven't done any calculus. I've just done some algebra. Maybe it's coming back the pre-cal day or two where we worked on this. Now we know why, because it makes our calculus life a whole lot easier. I'm going to pause it. Why don't you take the derivative of that? Is that what you got? I mean, chain rule, derivative of x is 1, derivative of x plus 1 is 1. Perfectly acceptable safe stop. I mean, you guys know by now, CalcChat likes to do all sorts of stuff with this stuff. So there's your free response safe stop. And by all means, free response question, don't mess it up by going further. I even think CalcChat and maybe the back of the book and maybe a multiple choice question would go one more step. Is there anything else you see that could be done with this? We're doing it right now in pre-cal. Adding fractions, so get a common denominator. Exactly, like, why would you do that? You probably wouldn't on your own, but CalcChat might. A multiple choice test might. Just to make sure your algebra is still functioning. All right, last one. Y equals the natural log of the natural log of x. I have no idea what that graph would look like. That's a weird looking thing. But this is a chain rule thing. It just so happens that it's like got 2 wrappers that are the same, or 2 layers that are the same. So the outside layer, in fact I may need to use my orange triangle here. taking the natural log of an orange triangle. So forget about what's in the orange triangle for now. Alright, so the outside layer is natural log. Derivative of y with respect to x. So derivative of natural log is 1 over, you know what, I'm going to just 1 over the orange triangle times the derivative of the orange triangle. Then we'll fill in the pieces. So the orange triangle is also natural log of x. This is a little bit weird. Derivative of the outside natural log is 1 over the argument, so 1 over natural log x times derivative of the orange triangle. Well, if the orange triangle is natural log, what's the derivative of natural log? 1 over x. So that's just kind of a weird one. It's a chain rule, which that's not that big a deal. It's just that both of the layers of the chain, or both of the links of the chain, are the same thing. So 1 over the argument times the derivative of the argument. 1 over natural log times derivative of natural log. Alright, today's assignment, which we'll have time to work on in class. That's fabulous. 328, 5 through 8 all. It might be a matching thing, is why I'm doing all of them. 41 to 61, 65, 73 to 77, and odd applies to all of that.